Okay, I'm going to go through them quickly if they're ones that don't take as much time. So yes, I'll speed through some, but the ones that take a while, I'm going to do the explanation slower. Again, if you're just checking your work, you can check your work and then go back and watch it if you missed it, right? Or you can watch the whole thing on the ones you're not sure about and fast forward to check your answers on the others. So let's talk about how you need to do this. I want you to go ahead and, if you get it read to you, you can hear me read it and then press pause and then try it, right? But if you don't get it read to you, I want you to press pause before I even start and try it on your own, okay? So I'm about to start reading it, and then if you then you start, press pause and all that. And I want you to do that with each one. And if you get really stuck, fine, press play and watch the explanation. It's study time, okay? That's fine to do. But if you are able to finish at least half of it on your own, then press play. That's better. If you can try it all the way on your own and then check, that's good too, okay? Use this how you need, but this is studying and figuring things out. And we've seen much of this before. And remember, this mirrors the unit test. So you could study this tonight. You can watch the video tonight again with this, especially if you don't finish. The test is 10 questions tomorrow, okay? Number 1. Mrs. Fuentes earned a salary of $60,000. So I'm reading it first. Mrs. Williams earns a salary of $51,000. Mrs. Fuentes will receive a salary increase of $1,525 per year. And Ms. Williams will receive a salary increase of $2,525 per year. Which equation can be used to find X, the number of years it will take Mrs. Fuentes and Ms. Williams to earn the same salary? Okay, so pause and try. Now I'm going to go through it. Okay, Ms. Fuentes earns $60,000. Okay, Williams earns $51,000. So on my paper, I'm going to start thinking about this. I have Fuentes and I have Williams. So Fuentes is $60,000. Williams is $51,000. Remember, we just start separating out the info. This is side notes. This is what you do when you have word problems. Ms. Fuentes will receive a salary increase of $1,525 per year. Remember this part right here? Per year, each month, something like that, a rate. That is going to have a variable with it. And I would have put this. I would have said, oh, she's getting an increase of $1,525 per year, a Y. So increase of $1,525 per year when I'm thinking about it, right? But they did say X, so we'd put an X there instead. And then Miss Williams will receive an increase of $25.25 per year. Again, increase per year. So we're just matching them up, right? And then now it's pretty easy because now I just have to make sure I describe the relationship between the two correctly. What's going on between them? Well, in the question it says, which equation can be used to find X? The number of years it will take Ms. Fuentes and Ms. Williams to earn the same salary. So here they just said it should be this. Fuentes, Williams, same. Well, we have Fuentes' salary represented here and Williams is here. So now we just have to have them equal to each other, right? So that same is the equal sign, just like this. So they're all equal, so that didn't really help. But do we have the variable by the 60,000? No, we don't. Do we have the variable by the 60,000? No, we don't. So all these can get crossed out. This is the only one that had our 60,000 plus this a year, 51,000 plus this a year, and then they're the same. Okay, let's look at the next one. Remember, pause and try. If you get it read to you, though, I'm about to read it now, then pause and try. Mr. Ward and Mr. Heskey are racing toy cars, and Mr. Heskey wants to give Mr. Ward an 8-foot head start because his car is 2 seconds slower. Mr. Ward's car travels 4 feet per second, and Mr. Heskey's car travels 6 feet per second. Which inequality can be used to determine after how many seconds Mr. Heskey's car will be ahead of Mr. Ward's car. Okay, we've seen one similar but not exact. Try it. Okay, let's go through it together. Mr. Ward and Mr. Heskey are racing toy cars. Mr. Heskey wants to give Mr. Ward an 8-foot head start. Okay, hold on. I have Heskey and I have Ward. Ward is getting the 8-foot head start, right? That's plus 8 because his car is 2 seconds slower. I don't know if I need this yet. We may not need this part. It may be a number in there to throw us off. Mr. Ward's car travels 4 feet per second. Oh, look, per second. So that's going to be a variable. So for multiplication. So Ward is 4 feet per second, but that 8-foot head start. Heskey is 6 feet per second. So Heskey is just this. He didn't have a head start. Which inequality? So we know it cannot be one with an equal sign in between, but that didn't help because they're all different. Not that. Could be used to determine after how many seconds Mr. Heskey's car will be ahead of Mr. Ward's car. So let's define the relationship first. They want Heskey to be ahead of Ward. So if I do Heskey ahead of Ward, that's the relationship, okay? This and this. Heskey ahead of Ward. Heskey's will be greater than Ward. So then it needs to look like this. The 65 needs to be greater than the 4s plus 8, or 4s plus 8 is less than 6s. So let's go see 6s greater than 4s plus 8. There it is. Let's just make sure. This has subtraction. No. 4s plus 8 is greater than, no, that's backwards. 4s, no, that's not even right. So it's this one. Okay, so it's about writing the expression and then identifying the relationship and putting it all together. Okay, this one, what value of x makes the equation true? So you're solving for x. This is where you go ahead and try it. And this is where you can solve it and then check it in your calculator with that math function, numeric solver. So make sure you check your work before you put your final answer. All right, let's do it together. So here's a regular way. I always have to rewrite it. Okay, and I know I went all my variables on one side and all my constants on the other side. I'm just going to do it this way. You could do constants and variables like that, but I'm going to do it like this. Okay, so I see I have x's here and then I have numbers here, right? So those are my constants. I'm going to move this 3.2 over here, and I'm going to move this 16.2 over here. So I'm going to use the inverse operation to get rid of the 16.2. That leaves me with 6.9x minus 2.36x equals 3.2x. Oh, but wait, I forgot. Whatever you do to one side, do to the other side. I didn't forget. I'm teaching that part. Okay, so here we have to go type it in. 13 minus 16.2. So when you type that in, hold on, let me get a calculator. 13 minus 16.2, because you don't need to put the plus sign, but you can do that minus part. We have to. So negative 3.2. So we're just going to bring down negative 3.2. Okay, so that's finished. We changed it to this. Now look what we have left. I need this over here. So what's the opposite of a positive? Negative. Bring it over here. You can't do anything with it yet. We're just going to tag it on. Remember, it's a little different. But I know for sure I have negative 3.2 here. But if I were like to rewrite this out, I'll go ahead and rewrite it just to show you. I'm just tagging on that new value. So then we'll do the math all at once. So we just put it over here, right? It's on the side. We kept its negative. We're good. Now we can do the math here. So 6.9 minus 2.36 minus 3.2. So I just am going to subtract all of those because that's what's in between them, subtraction sign. And I get 1.34. But it's an x. Don't forget its last name. And then it equaled negative 3.2. Almost done. We're at our last step. We need to divide by 1.34, right? Because this is multiplication. The opposite of multiplication is division. I'm going to come up here and show my last step. This is where we were at. This is almost like a 6th grade problem because it's just one step left. I'm going to use the inverse of multiplication, which is division, to get rid of it here. But whatever you do to one side, you do to the other side. So negative 3.2 divided by 1.34 is negative 2.388. I'll round to 2.39, okay? On your test, it won't be a rounded one. It'll be an exact answer. And like here, you can't bubble in that negative. But anyway, that's what it is. And here's how you check your work. So math, up, numeric solver, enter, clear. Let's type that in. 6.95x, the x button's here, plus 16.2 minus 2.36x. It should look just like that side, expression 1. And then I'm going to come down, press clear. 3.2x plus 13 is the other side. Don't hit enter, but hit graph, graph. Remember, graph, graph. And it shows negative 2.3021, blah, 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 blah. So either way, we're on the right track. I might have made a mistake when I typed something in over here. 6.95, 16.2 minus 2.36. Anyway, I probably typed something wrong over here or wrote something slightly wrong, but this is the process, okay? So don't worry about that. On your test, it's not going to be a negative because you're going to have to be able to fill it in here. It's going to be a positive whole number, and it won't be anything that you have to round like what I did there when I ended up rounding. So don't worry about that. Yeah, I probably typed something wrong. But anyway, this is good enough. If you got this or that other one, let me find where it is. Hold on. This or this, we're okay. All right, next. Number 4. Which equation can be represented by this equation? What? Which problem situation can be represented by this equation, okay? So try that. All right, if we go look at it, we have subtraction going on. We have our per or each right here, right? Per or each on both of these should be with the 2 per or each, 6 per or each. So let's go read. Tank A has 100 gallons of water and gains, oh, does that make sense here? No, bye. Tank A has 100 gallons of water and loses, that's good, 2 gallons per hour. Didn't I say 2 per? That's good. So check, check. Tank B has 140 gallons and loses, yay, that's good, 6 gallons per hour. And I said 6 per or each up there, so yes. When will the tanks have the same amount? Well, that one matched perfectly because all that stuff matched plus same. Okay? We're not going to check the rest. But I see gains. We don't do gains here. And I see loses here. But it says more than the other. And we're not looking for that. Okay? Next. A rectangle's perimeter and area have the same numerical value. Okay, so perimeter equals area. Before I even move on, remember we need that formula. We need 2 lengths plus 2 times the width equals length times width. So we know 2 times the length is the same, but they gave us the width, so 2 times 9. And then length times width. Well, we know the width is 9, but we don't know the length, right? So we can start figuring this out. So 2 times the length plus 18 equals 9 times the length. Now we just need to put this over there or type it in your calculator and see what you get, right? So just to save a little time today, we'll do the calculator way on this once we get it this far. And we'll type in 2x plus 18. And down here we'll type in 9x, graph. And I got L equals 2.57. And if I were to work that out, like on your test again, you're not going to have to round. If I were to work that out, that would have been, 18 divided by 7. Yep, that's right. So the length is 2.57. On your test, it won't be that way. But anyway, ignore all this over here. So next. Actually, I'm going to pause that there and do the second half on another video.